Hello everyone and welcome to our last practice video about the 6 trigonometric ratios. So in this video, we're going to use our knowledge about the inverse trigonometric functions in getting the acute angle in a given right triangle. All right? So we have three triangles here. One is this one, and this one. Though the vertices, the corners of the right triangle, they have the same name. So I decided to not to change it. Only the sides are the ones I'm gonna change. Okay. So now our goal here is to find the acute angles. Okay. So that means we're not going to focus at this part, which is, for example, you're going to find the angle here, but also we're going to find the angle here as well. Okay. So without further ado, let's now begin. Suppose we decided to focus at finding the angle n. Okay, let's find angle n. So that means angle at n here. And you have two sides given. And these two sides are basically the legs of your right triangle. And these are your 12 units and 16 units. So how will you find the angle n? So last time I told you that in getting the missing angle in a given right triangle, you can use any trigonometric ratios as long as it's correct. Okay, but the highly recommended trigonometric ratios that you are going to use in terms of finding the missing angles are sine, cosine, and tangent. I explained this one last time, okay? Because these three trigonometric functions, if you're going to find its inverse, not only that it is more convenient than the other three trigonometric ratios, but these inverses, the inverse of sine, inverse of cosine, and inverse of tangent, these are present in your scientific calculator. I am not sure that there are scientific calculators consist of having an inverse of cosecant, inverse of inverse of secant, and inverse of cotangent. I am not sure about that. Unless if they have, then that's good for them. However, in usual cases, it's only the inverse of sine, the inverse of cosine, and the inverse of tangent. These three trigonometric functions has its inverses in a scientific calculator. In fact, in a scientific calculator, only sine and cosine and tangent are present. Okay? So basically, it's up to you if you're going to use secant, cosecant, but you're going to use its equivalent. Okay? But for me, I would rather suggest using these three trigonometric ratios and its inverses, especially the fact that our goal here is to find the missing acute angle in the right triangle. But here's the question though. Which one? Should we use sine? Should we use cosine? Should we use tangent? The answer is any. As I told you, any. But we have only two given sides. To be particular, we have only two sides that are the legs of the right triangle. So which one should we use? First and foremost, you need to know the parts first of the right triangle. Okay? So first we have the hypotenuse, the opposite, and the adjacent. How would you know if the side or the leg is opposite and the other is just the adjacent? It depends on the angle we are referring to. So now that we are referring to the angle n, right? So there we can find our opposite side and angle side. So, sorry, adjacent side. Adjacent side is basically a side that is beside with the angle. Basically, it's adjacent. So that means 16 is beside to theta. So this is your adjacent. The other one, it's not adjacent to the angle. Okay, it's not beside with that angle we are referring to. So that means 12 is your non-adjacent side or the opposite. And of course, in a right triangle, the slanted one, which is basically the longest side, that is your hypotenuse. Now, as you can see, opposite and adjacent opposite and adjacent are the only given sides. So, which of the three should we use? Should we use sine? Remember that sine theta is equal to the ratio of the opposite to the hypotenuse. Cosine theta is equal to the ratio of the adjacent side to the hypotenuse. And here we have tangent theta is equal to the ratio of opposites to the adjacent. So which one should we use? We are going to use tangent theta. Why tangent theta? Because the opposite side and the adjacent side are given. The only thing missing here is hypotenuse. So let's just say you want to find the hypotenuse then it's okay. There's no problem. But if you're in a hurry, just basically know the given sides and which of the trigonometric ratio you should use. That's it. Okay? So we're going to use tangent theta because it has opposite side and the adjacent side. So tangent theta is equal to their opposite 12 all over adjacent 16. So we're going to put the word tan here. So we will have theta is equal to arc tangent. Remember, this one, again, if you see this one, this is not the same as this one. Okay? They are not the same. This one, it's the inverse. This one, it's reciprocal, which is, in other words, 1 all over tangent. Okay? So these two are not the same. Remember that. These two are not the same. Or you can simply rewrite this as arc tangent or arctan. So it's up to you. But going back, so yeah, you put the word tan here, so you will have arctangent of 12 all over 16. We can simplify the fraction here because 12 and 16 are both divisible by 4. Right? They're both divisible by 4. So 12 divided by 4 is 3 and 16 divided by 4 is 12. It's 4. With that, we can use our calculator here. So arctangent, wait, arctangent of 3 all over 4 will give you approximately 36.87 degrees. And we're done. That is your angle N. This is 36.87 degrees. Okay, 36.87 degrees. Oh, that's it. Okay, that's good. We're already good to go. Okay, now, how about we find the angle C? Okay, how about angle C? All right, or angle at C. Can we do that? Yes, and there are two ways. One, which is the simple way, like with the application of geometry, or two, just use trigonometric ratios. Okay, so let me just erase this one. Let's start with the first one, the simplest one. And then, no. I think let's start first with the trigonometric ratio since the topic here is about trigonometric ratios. So here, how about C? Okay, what is angle C? Okay, so now we're going to observe the triangle first. Okay, so the angle we are referring to is at C, and the sides are given, but the sides are the lengths of the right triangle. So 12 and 16. Now, the question here is which one of them is the opposite and which one is the adjacent. Remember, adjacent is next to the or beside to the angle. So meaning 12 is beside to the angle, that will be your what? Adjacent. And here, your 16, it's not adjacent to the angle C, meaning it's not beside to the angle C. Therefore, we can represent your 16 as your opposite. And with that, we're going to use the same trigonometric ratio, which is tangent theta is equal to opposite all over adjacent. And why? Because only the opposite and adjacent are given. So now let's substitute. So your O is 16 and your A is 12. So put the word tan to the other side, you will have arctangent of 16 all over 12. 16 and 12, once again, are both divisible by 4. So 16 divided by 4, it's 4, and 12 divided by 4, it's 3. Okay, so now we can get our scientific calculator. So arc tangent of 4 divided by 3, it's approximately 53.13. Wait, once again, it's 53.13 degrees. Okay, that is your angle C. Okay, so yay, we're good to go. But remember, I told you that there's another way, which is for me the simplest one. Okay, the simplest way. All you need is apply what you've learned in algebra, in geometry. Okay, so let me erase these three. Okay, let me erase these three. Hold on, for a while. If only I have a tool here that I can use to uh, select a group of handwritings here, then I can just delete easily. Okay, so there's another way. Okay, in geometry, in a geometry, we learn about the angles in a triangle. So it could be a right triangle. I mean, right triangle looks like this, right? Right triangle, or an acute triangle, or an obtuse triangle. It doesn't matter what type of triangle we are referring to. All it matters is its sum of all interior angles, or SIA in other words, sum of all interior angles. Basically, you're going to add all of the interior angles. And what are those interior angles? Those interior angles are basically angles inside of the triangle. So we have this one, and this one. These three are your interior angles. This one, this one, this one, these are your interior angles. And lastly, this one, and this one, these are, once again, your interior angles. Basically, interior angles are located on the corners of your triangles. So in that corner, there's always a given right triangle. Just like this, in this case, we have right angle, which is a 90-degree, by the way. We have an angle here and we have an angle here. So each corner has an angle. Okay? So here's the thing. If you're going to add them, like all of them, which basically means summing up all of the interior angles in a right triangle, it's always equal to 180 degrees. Okay? If you're going to add all of the interior angles, they should sum up to 180 degrees. Okay? So suppose that this one, you see it's missing. Okay? It's missing. Okay? Just assume that it's missing. We don't know that it's 53.13 degrees yet. Okay? Not yet. So here's what we're going to do. We're going to add all of the angles here. Okay, so we have angle C plus angle A plus angle N is equal to 180 degrees. Angle C is missing. Angle A, which is your right angle, so it's 90 degrees. And your angle N, which is 36.87 degrees. Okay, so here, as you can see in this equation, there's only one missing variable or missing angle. So with that, we can find that missing angle by applying what we learned in geometry, which is basically, let's find angle C in this equation. So first, let's add 90 and 36.87. So 90 plus 36.87, this will give you angle C plus 126.87 degrees is equal to 180 degrees. Then we transpose 126 to the right. So we will have angle C is equal to 180 degrees minus 126.87 degrees. So with that, your answer is exactly 53.13 degrees. See, that's it. Okay, that's it. So, wait. Wait. There you go. Yeah, that's it. See? So it's up to you. All right. So if you're going to apply the second technique, which I discuss it right now, you must find two angles. Okay, you must find two angles. First one, of course, you have the right angle, and we have this one as your angle. Okay, so find first the two angles, or basically, wait, let me rephrase it. You must have two given angles. Okay, for you to apply the second technique, which is basically the application of what we've learned in geometry, you must have two given angles for you to find the missing angle, which is just like this. We have angle A, which is 90 degree, angle N, which is 36.87 degrees. So you have two given angles. Now with that, you can find the missing angle, just like what we did here. Okay, all you need is again two given angles. Otherwise, just use the first technique. Okay, you just use the uh, trigonometric ratios, if you know what I mean. Okay, so yeah, basically that's it. Okay, that's how you got it. Okay, there are other ways also to solve this one. Okay, you can use the reciprocal trigonometric, what is this one? Reciprocal trigonometric ratios, which is cotangent theta. Okay? Because remember, cotangent theta, it's the reciprocal of tangent theta, or it's 1 all over tangent theta, which is, in other words, it's adjacent all over opposite. And we have opposite and adjacent here. So there you can find its inverse, inverse arc cotangent. I mean, inverse of cotangent. So you will have theta is equal to arc tangent of A all over O. However, again, as I told you earlier, that in your scientific calculator, you don't have cotangent, especially its inverse. So you're going to use its equivalent. Okay? This one, it's just the same as arc tangent of 1 all over what? Cotangent theta. Or in other words, this is arc tangent of 1 all over A all over O. Okay? So instead of using this, just use this one. Okay? Just use this one. This one right here. Okay? Just use that one. Okay? And the answer is still the same. Okay? It's still the same. Right? And others, they prefer, let's find all the sides first. Like, for example, you have the opposite and adjacent, right? Now, uh, let's find hypotenuse. Well, yeah, it's okay. Just apply Pythagorean theorem. Then after that, use any trigonometric ratio because you have the opposite, you have adjacent, and you have hypotenuse. So with these three, you have like a lot of choices that you can use. You can use sine, you can use cosine because you already found your hypotenuse. But for me, I think it's better not to find it. It's better. Just refer to what do you call this one? Just refer to the given sites. Okay? Just refer to the given sites. All right? With that, I think that would be much better and much more convenient because you're going to how should I say this? Maybe you're going to hassle yourself if you know what I mean. It's like it's you're making yourself more complicated. All right? So anyway, whatever your preferred method is, the answer should be the same. Okay? The answer of angle C should be 53.13 degrees, and the answer for your angle N is 36.87 degrees. All right? So let's go to the next example. Okay, let's just say the same corners, C, A, N, still the same, but the units are different. Okay? So the same goal. Find the angle N and find the angle C. Okay? And you have your given, what's that again? Given sides. Okay? So let's go. Now, let's just start with finding the angle N. So angle at N. So we're referring to the angle here. Now, after that, we need to know the parts of the right triangle. This one is very obvious. The one that is the longest one, that is your hypotenuse. Okay? And here we have the angle that we're referring to, which is your angle N. So this side AN, which is 6 units long, this one is beside to that angle. So that means that is your adjacent. Again, adjacent, it's next to the angle. This one right here, which is, it has no given side, which is this one, basically this one. It has no given length of this side, okay? And it's not beside to angle N. So this is your opposite. Now, if you're going to observe, hypotenuse and adjacent are given. They are given. So with that, we're going to use either cosine theta, because cosine theta is equal to adjacent all over hypotenuse, or secant theta is equal to the hypotenuse all over A. Because both of them have adjacent and hypotenuse. Okay, so it's either of the two. So now let's find cosine theta. Okay, I mean, let's find the angle with the use of cosine. So put the word cosine to the right. So you will have theta is equal to cosine, arc cosine, sorry, of your adjacent all over your hypotenuse. What is your A, which is your adjacent? So your A is 6. Your hypotenuse, it's 2 square root of 10. 6 and 2 square root of 10 are both divisible by 2, so we can simplify them. 6 divided by 2, it's 3. And 2 square root of 10 divided by 2, it's square root of 10. We can stop right here if you want to, or we can still simplify that. Because in a fraction, as much as possible, do, we, the denominator should not have a radical term, or in other words, a term that has a root. Okay? So here, in the term here, we have a square root. So how can we remove that square root on the denominator? Because that's the common case on how would you simplify. Okay, sorry, that's how you, I mean, sorry, wait. That's a common case in terms of simplifying. Because, for example, you have A all over square root of B. They want to have a radical term here to be removed. Because they want to, what do you call this one? They want to remove the root on the denominator. So what we're going to do is we will rationalize. So A all over square root of B is equal to A all over square root of B times square root of B all over square root of B. So we're going to multiply both sides of the fraction by the denominator itself. So what will happen is we will have A square root of B all over square root of B times square root of B. What will happen is we will have B. So see, there's no more root on the denominator. Okay? So with that, we can do the same thing here if you like to. So here we will have 3 all over square root of 10 times square root of 10 all over square root of 10. With that, we will have our cosine of 3 square root of 10 all over 10, I mean, square root of 10 times square root of 10 will give you just 10. And yes, there we go. Now we will use our, what's that again? Our scientific calculator. So our cosine of 3 square root of 10 divided by 10. This is approximately 18.43 degrees. Okay? So angle N, it's 18.43 degrees. Okay? 18.43 degrees. Okay? So that's it. If you wish to use secant theta, okay? I mean, the inverse of secant theta. Wait. Let me just erase my handwriting here. Wait for a while. just for a second. Okay? If you want to see the solution, just pass backward. Okay? So going back, if you wish to use arc secant, there's no problem. But you're going to use its equivalent. Okay? So remember that arc secant of h all over a, h all over a is just the same as arc cosine of 1 all over h all over a. Okay? They're just the same. So if you wish to use arcsecond, use its equivalent, okay, which is this one. All right. Now let's find your angle C. So I taught you the second technique, right? So that's the technique that I will be doing here because it's far more convenient than using the trigonometric ratio. Okay. So with that, let's apply the second technique. Okay. So we have two given angles already. We have the 90-degree and we have 18.43 degrees. So let's find angle C. Okay. Angle C plus angle A plus angle N is equal to 180 degrees. So angle C plus your angle A, which is 90 degrees, plus angle N, which is 18.43 degrees. So let's add first the 90 degrees and 18.43 degrees. So we have 90 plus 18.43. We will have 108.43 degrees. Now with that, we will transpose it to the other side. So we will have angle C is equal to 180 degrees minus 108.43 degrees. Okay, so with that, we will have 180 minus 108.40 degrees. We will have an angle of exactly 71.57 degrees. And that is our answer, 71.57 degrees. There we go. Okay, there we go. That's it. We're done. Okay, but again, if you have your own technique, it's okay. There's no problem with me anyway. All right, as long as it's correct. Okay. Now let's apply it to the last problem. So here, okay, same letters. Same letters for each of the vertices of the right triangle, but the difference is the sides. As you can see here, we have 20 units and 10 square root of 20. So same thing, let's find the acute angles here. So let's find angle N and angle C. Okay, both of them. All right. By the way, I forgot to mention, you can find first the angle C before you find angle N. It's up to you. Okay? It's not in order. So yeah, it's up to you. Going back, so let's find angle N. So we are referring to the angle N. Now, you must know the parts of the right triangle. This one is pretty obvious. This is your hypotenuse. Now, how will you know, again, if the side is adjacent and this side is opposite? If it's next to the angle, it's adjacent. Otherwise, it's opposite. As you can see, 20 is not next or beside to the angle. So this is your opposite. Okay, now you know the parts. Now, what trigonometric ratio should you use? So you can either use sine theta, because remember, sine theta is equal to the ratio of the opposite to the hypotenuse, or you can use cosecant theta, which is the ratio of the hypotenuse to the opposite. Okay, so now let's find the missing angle. So let's first substitute. So your opposite is 20 and your hypotenuse is 10 square root of 20. Okay, so put the word sine to the right. You will have theta is equal to arc sine of 20 all over 10 square root of 20. These two numbers are both divisible by 10. 20 divided by 10, it's 2 all over 10 square root of 20 divided by 2, it's, oh, no, no, no. 10 square root of 20 divided by 10, it's square root of 20. Okay? And we can still simplify this one because we have a radical term on the denominator. We can rationalize. Okay? So here we can have 2 all over square root of 20 times square root of 20 all over square root of 20. So the answer here, arc sine of 2 times square root of 20, so 2 square root of 20, all over square root of 20 times square root of 20, it's 20. And we can still simplify this one because 2 and 20 are both divisible by 10. Okay? So let me just put it here. So 2 square root of 20 oh wait, no. Sorry. 2 square root of 20 and 20 are both divisible by 2. Okay, it's 2, not 10. Forgive me. So 2 square root of 20 divided by 2, it's just square root of 20. And 20 divided by 2, it's 10. And yay, there we go. So with that, let's now find our angle with the use of our scientific calculator. So arc sine of square root of 20, right, square root of 20 divided by 10. So this is approximately at 2 decimal place. This is 26.57 degrees. Okay, that is your angle N. Okay, 26.57 degrees. So here, uh, you can now find the angle C with the use of second technique. Okay, or again, it's up to you. You can use a trigonometric ratio to find angle C. Okay, but for me, I'm going to use the second technique. Also, if you wish to use cosecant theta, there's no problem because I mean the answer is still gonna be the same, you know. So it's up to you. But in a scientific calculator, we don't have usually we don't have cosecant and its inverse. So you're going to use its equivalent, which is arc sine of 1 all over hypotenuse all over O. Okay? That's it. Okay? If you're going to use the inverse of cosecant, if you're going to use the inverse of cosecant, just use this. Okay? That's it. Now, what we're going to do is we will find angle C, which is for me the easiest one because I'm going to apply the second technique. It's up to you, once again, if you're going to use a trigonometric ratio for that. Okay? But for me, I would prefer the more convenient way, which is the second technique. All right? So, again, we have two given angles. The angle A, which is 90 degrees, and N as what? 26.57 degrees. So, angle C plus angle A plus angle N is equal to 180 degrees. So angle C plus your angle A, which is 90 degrees, plus angle N, which is 26.57 degrees, is equal to 180. So if you're going to add 90 by 26.57 degrees, you will have 116.57 degrees is equal to 180 degrees. Am I right? Wait. Uh, 90. Just making sure, guys. I don't want to jump to conclusion that easily. Okay, it's correct. Now transpose 116 to the right. So angle C is equal to 118 degrees minus 116.57 degrees. So the result will give you exactly 63.43 degrees. Just making sure. Hold on, just making sure. 180 minus 116.57. Yes. So the angle C here is 63.43 degrees. And that's it. Okay. So now we're done with our practice video for today. Now, the next video we're going to discuss is some of the properties of the trigonometric functions. All right. Then after that, we can now proceed to the next subtopic that we're going to learn, which is the application of the six trigonometric ratios, which are the angle of elevation and the angle of depression. See you soon.